Hi everyone. We're going to work our way through 11.4 right now. AA similarity. So by now you should figure out that AA stands for angle angle. And it has to do with similarity. And in fact, it's a similarity theorem just like our triangle congruence theorems, except for the fact it's just similar. So basically it says that if we have two triangles and two of the corresponding angles are congruent, then we can say that the triangles are similar.
What's the difference between similar and congruent?
Remember, similar triangles have the same shape, but they might not be the same size. So this makes sense if we think about the triangle sum theorem, right? If we have this triangle, that angle is congruent to that angle, this angle is congruent to this angle, then from the triangle sum theorem we know that this angle must be congruent to this angle, and it's pretty obvious that all the angles are congruent here, all the angles are congruent here. Therefore, those triangles are the exact same shape. They may not be the same size, and that's okay. As far as similarity is concerned, we're just concerned about shape. So there's an angle-angle similarity theorem to prove that the two are similar. Here's a question for you, dear. We have triangle JKL. You with me?
So far.
Okay. Angle J is 40 degrees. Angle K is 55 degrees.
Okay.
We have another triangle, MNP, right?
Okay.
Angle M is 40 degrees. Angle P is 85 degrees. A student concludes that the triangles are not similar. Do you agree or disagree? Why?
I disagree.
Because?
Because 40 and 55 and 85 all adds up to a triangle.
Very good. Yep. So essentially the missing angle here is angle JK is angle L. So you're saying that angle L here is 85 degrees.
Yes.
And so therefore it's angle L that corresponds with angle P, and angle M can correspond with angle J, and you can use angle-angle similarity. Cool.
Basic addition.
Nice
Addition.
Wow. In front of high schoolers, no less.
No.
Don't do addiction. Addiction's
Don't do
bad.
it. It's bad.
Okay. So for this one here, sorry, it's a little hard to see, but we're gonna find there's our figure. It's asking us to figure out what the length of RT is here, and what they've done here is it's kind of clever. They've overlapped these two triangles. So remember, since they both share this angle, angle R, we can conclude that these two triangles are similar because this angle here is congruent to this angle is congruent to itself, right? Reflexive property. So therefore, the two triangles are similar, and therefore the ratio between the sides must be preserved. So we've covered that. Yep. Okay. So our two triangles are similar. So that means that RT here, this big side, do it purple, yes, that there. So RT over RS has to be equal to, we'll do more colors, TU, right, over SV. Okay. Again, there are multiple ways to set up these ratios, but the important thing here is that we've set them up so that in this case we've put it so the corresponding sides here make a ratio, and this corresponding side here makes a ratio. So then we can just fill in our blanks. Solve for a missing side. Multiply, divide, we get 15. Cool. All right, we'll give you these ones. We didn't go over that one. just remember there are multiple ways to set up those ratios, right? Instead of using the corresponding sides, we could have set up the same triangle sides, right? So you could just put RS over VS is congruent to RT over UT, as long as then the two top ones and the two bottom ones are then the corresponding sides. That works too. Okay, when asked to solve for y, a student sets up a proportion as shown. Explain why the proportion is wrong. How should you adjust the proportion so it'll give the correct result? Again, he didn't set this up. He picked one of the wrong ways to do it. He said that y here over 8 is equal to 14 over 10. What he needs to do is use that for his numerator here. So in this case, he could use y plus 8. So y plus 8 over 8 equals 14 over 10. That would work. Yay. Okay. See if you can do 6 and or 7 real quick. So pause here. So we got 10 for the first and 11 for the second. Okay, note here we have some other similarity theorems. These ones are pretty obvious because these ones are the same as our congruence theorems. We have side, side, side. We have side, angle, side. Why don't we have an angle, side, angle, or an angle, angle, side? Similarity theorem. Well, as it turns out, if we have two angles, that's all you need, right? There's our angle, angle similarity theorem. We don't need the side. It's totally superfluous. And in fact, the side here, when we're talking about sides, we actually are talking about the ratios of sides. So we need two sides in order to kind of look at the ratios of those sides. Similarly here, we have two angles. This side is superfluous. We don't have two sides to look at the ratio. So for example, this one, if three sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles are similar, right? Here, if we have two proportional sides and then a congruent angle, then we can say those are similar. So that rounds out our triangle similarity theorems. And we'll go ahead and use them real quick. Here's a quick example. We have these two triangles. We have to determine if they're congruent, or similar, sorry. These angles are congruent. So then we have to figure out if these sides are proportional. And I would just say is 4 over 6. Is that equal to, in this case, again, I'm going to do the small triangle first, 8 over, and then the long one here isn't 4, right? It's 8 plus 4. This 8 refers to that part. So that's 12. Is 4 over 6 equal to 8 over 12? Yes. So we're good. We can conclude that they are similar using the side angle side triangle similarity theorem. Similar with this guy. We don't have any angles, so at this point we're just going to use sides. And we can look at the proportion of the sides. What we want to do is we want to set it up so we have ratios of the two largest sides, the ratios of the two smallest sides, and the ratios of the two middle sides. So I would pick the two largest ones, that's JH and MN, and do that first. Which comes out to 3 over 2. And then I'd pick the two smallest, which is GJ and LN, which comes out to 3 over 2. And then finally the two middle ones, which also comes out to 3 over 2. Therefore, we can conclude that they are similar using the side, side, side triangle similarity theorem. Cool. Are all isosceles right triangles similar? So remember, if it's an isosceles right triangle, it has a 90-degree angle, and this side must be congruent to this side. Or another way to think of it is this angle must be congruent to this angle. So are they all similar? Yes, they are. All 90, 45, 45 triangles, therefore, yes, they're all similar. Why is an angle side angle used to prove two triangles similar? Again, the side here is superfluous, and we can't really say it's proportional because we only have one pair of sides. So you get a ratio, but what does that mean? You need two of the ratios. Okay, see if you can do 10 and 11 real quick. This one doesn't work because we don't have enough stuff set up for it. And this one, we have to get clever and use the Pythagorean theorem to find that missing side. So it's kind of like hypotenuse leg thing, but yeah, more like we can just use side, side, side. Okay. Hey, wife, I got a question for you.
Oh no.
Is triangle similarity transitive? If triangle ABC is similar to triangle DEF, and triangle DEF is similar to triangle GHJ, is triangle ABC similar to triangle GHJ? What do you think? Yes, no, maybe?
I'm gonna guess what transitive means, and I'm gonna go with a yes. Because if these two, if ABC and DEF are similar, they would have
Same shape?
congruent angles, the
yeah.
same shape. And if DEF is likewise similar to GHJ, it would also have the same shape with the same angles.
Yes, very good. Yep. If these two have the same shape and these two have the same shape, then all three of them have the same shape. Good job.
I used all the right words.
Well done. Yeah. And it's a good application of the transitive property. Okay, that's it. That's all I got. Yeah, have a good one. Thank you, dear.